In the vastness of space, everything we see, the stars, the planets, the glowing galaxies, makes up only a small fraction of the universe. The rest, the majority of it, is invisible. It neither emits nor absorbs light, and yet it exerts a powerful gravitational pull that shapes the cosmos itself. This unseen force is called dark matter. Scientists estimate that dark matter accounts for about 27% of the entire universe. By comparison, all the normal matter, the stuff that makes up stars, planets, humans, and everything we can touch, makes up only about 5%. The remaining 68% is something even stranger: dark energy, the mysterious force pushing the universe to expand faster and faster. But while dark energy drives expansion, dark matter holds everything together. Without it, galaxies would simply fly apart. So what exactly is dark matter? To answer that, let's first look at what it is not. It's not made of atoms, molecules, or any form of matter that we're familiar with. It doesn't interact with light or other forms of electromagnetic radiation. That's why telescopes can't see it, no matter how powerful they are. And yet, we know it's there because of the way it bends light and pulls on galaxies. The idea of dark matter began nearly a century ago. In the 1930s, Swiss astronomer Fritz Zwicky observed a cluster of galaxies known as the Coma cluster. He calculated that the galaxies inside were moving much faster than they should have been, given the visible mass present. By all logic, the cluster should have torn itself apart. But it didn't. Something unseen was providing extra gravity, an invisible glue keeping the cluster bound together. Zwicky called this missing mass Dunkle Materie, dark matter. Decades later, in the 1970s, American astronomer Vera Rubin provided the strongest evidence yet. She measured how stars orbit the centers of galaxies. According to Newton's laws, stars farther from the center should move more slowly, just as planets farther from the sun take longer to orbit. But Rubin found something astonishing. The stars at the edges of galaxies were moving just as fast as those near the center. The galaxies were spinning so rapidly that by rights they should have been ripped apart, unless some unseen mass was holding them together. That missing mass, again, was dark matter. Today, thanks to advanced instruments, we can see the effects of dark matter in even more detail. Not by detecting it directly, but through its gravitational influence. When light from distant galaxies travels through space, it sometimes passes near massive clusters of dark matter. The gravity of that mass bends and distorts the light, a phenomenon known as gravitational lensing. It's like looking through an invisible magnifying glass made of gravity. By studying these distortions, astronomers can map where dark matter lies, even though they can't see it directly. But what is it actually made of? That's the question that has puzzled physicists for decades. There are several theories, each stranger than the last. One of the leading ideas is that dark matter consists of WIMPs, weakly interacting massive particles. These are hypothetical particles that barely interact with normal matter. They don't emit or absorb light, but they have mass, so they can exert gravitational force. If WIMPs exist, trillions of them are passing through your body every second, but you don't feel anything because they almost never collide with ordinary atoms. Another candidate is axions, tiny particles that might have formed shortly after the Big Bang. Axions would be so light and elusive that detecting them would be nearly impossible, but they could collectively make up the universe's missing mass. Some physicists even speculate that dark matter might be made of primordial black holes, ancient microscopic black holes formed just after the Big Bang. They would be invisible today, but their gravity would still shape the cosmos. But despite decades of searching, no one has yet directly detected dark matter. Huge underground detectors buried deep beneath mountains or in old mines are constantly looking for signs of it. For example, when a WIMP might collide with a single atom of xenon or argon. But so far, nothing definitive has been found. That doesn't mean it doesn't exist, it simply means it's more elusive than we ever imagined. Yet even without seeing it, we can measure its fingerprints everywhere. Dark matter forms a vast, invisible web stretching across the universe, known as the cosmic web. Galaxies aren't scattered randomly, they gather along the dense filaments of this web. Think of it like a spider's web made of gravity. Wherever dark matter is densest, galaxies form, grow, and cluster together. In fact, without dark matter, the universe as we know it couldn't exist. Its gravity acted as a cosmic framework, pulling together gas and dust in the early universe, giving birth to the first stars and galaxies. If we could somehow remove all dark matter from the universe, galaxies would unravel, stars would drift apart, and the night sky would slowly fade away. Dark matter isn't just a mystery, it's the silent architect of everything we see. Even our own Milky Way galaxy is surrounded by a vast halo of dark matter extending far beyond the visible disk of stars. This halo is several times more massive than all the visible matter in the galaxy combined. Every time the Earth orbits the Sun, it also moves through this invisible ocean of dark matter, a sea of unseen particles that neither collide with nor affect our daily lives directly, but define the shape of the cosmos. The search for dark matter is one of the greatest quests in modern science. Scientists use particle accelerators like the Large Hadron Collider to recreate conditions from the early universe, hoping to produce dark matter particles. Others build massive detectors deep underground, shielded from radiation and cosmic rays, waiting for the faintest signal. And in space, telescopes like the James Webb Telescope and Euclid mission are helping us map the distribution of invisible mass across billions of light years. But here's the fascinating twist. It's possible that dark matter might not even be matter at all. Some physicists propose alternative explanations. Maybe the laws of gravity themselves behave differently on cosmic scales. Theories like modified Newtonian dynamics, or MOND, suggest that what we interpret as dark matter could simply be an effect of unknown physics. If that's true, our understanding of gravity and the universe would need to be rewritten from scratch. Whatever the answer, dark matter reminds us of how little we truly know. For all our technology and telescopes, 95% of the universe is invisible and unknown. We are surrounded by mysteries we can't touch or see, yet we feel their effects every time we look at the stars. Dark matter may be invisible, but it's not absent. It binds galaxies, shapes space, and defines the structure of the universe itself. It's the silent force weaving together the fabric of existence. And somewhere, hidden in that darkness, lies the key to understanding not just what the universe is made of, but why it exists at all. Don't forget to like, share, and subscribe to WiseUse, where we bring the universe closer, one mystery at a time.